Now let's continue from where we stopped on related acute angles. Let's recall what we established in the last lesson. Here we have 4 quadrants. We have the first quadrant ranging from 0 degrees to 90 degrees. We have the second quadrant ranging from 90 degrees to 180 degrees. We have the third quadrant ranging from 180 degrees to 270 degrees. And we also have the fourth quadrant ranging from 0 degrees down to ranging from 270 degrees down to 360 degrees. So in that case, the acute angle in this case, x, is equals to theta, because we just have theta here. Similarly, in the second quadrant, we have an angle represented in the second quadrant, and we call this angle theta. The value of x in respect to the positive axis or the x-axis, we call this that x is equals to 180 degrees minus theta. Moving on, let's say now we have in the third quadrant, the angle is coming from the positive x-axis passing through the negative x-axis, and we call it angle theta. The relative angle in this case, x, we say that x is equals to theta minus 180 degrees. And finally, for the angle in the fourth quadrant, we have an angle here, and we have an angle theta. The relative or related acute angle, let's call this angle x, and we know that x will be equals to 360 degrees minus theta. So this is a simple representation of related of equivalent, related, relative acute angle. Whatever word we use, it's correct. Now let's take some examples to establish understanding on this before we move to the next theorem of how then do we find the sine of an angle, the cosine of an angle, the tangent of an angle across all the quadrants. So let's have an angle. Let's call it angle 200 and let's use 210 degrees. Now 210 degrees, according to the exercise we had before, 210 degrees is greater than 180 degrees, but then it is less than 270 degrees. So this represents the third quadrant. Now we can easily just say that, oh, this is the relative angle formula for the third quadrant, and just say the relative acute angle x will be equals to theta minus 180 degrees. So this will give us 210 minus 180 degrees, which is equivalent to 30 degrees. But then how do we get there? Let's use a diagram to depict this. We're in the third quadrant. Let's use this third quadrant. The angle coming from the origin, the positive x-axis, is 210 degrees. The related or relative, whatever word, it can also be equivalent acute angle, is x. We understand that the angle on a straight line is 180 degrees. Therefore, x is simply going to be 210 degrees minus 180 degrees, which is 30 degrees, just as we have here. Let's proceed. Let's have number 2, 10 degrees. What position does 10 degrees fall in? 10 degrees is in the first quadrant, second quadrant, third quadrant, or fourth quadrant. These are the questions we ask. So we say that 10 degrees falls in the first quadrant, because 10 degrees is greater than 0 degrees and then it is less than 90 degrees. So it is in the first quadrant. So let's draw a diagram to represent the first quadrant, and we'll have 10 degrees. Now, what then is the equivalent acute angle or the relative acute angle? We will see that in the first quadrant, the related acute angle is simply x is equals to theta. Theta is equals to 90 is equals to 10 degrees. Therefore, the related acute angle is equals to 10 degrees. Let's have another example. Question 3 now. Let's have angle 135 degrees. You can pause the video now and give this a try. Angle 135 degrees. Okay, let's proceed. The first thing is to know that angle 135 degrees is in which quadrant. So we can say that angle 135 degrees is greater than 90 degrees, but then it is less than 180 degrees. So that means this is in the second quadrant. Emphasis must be made on this quadrant analysis before we even think about proceeding to evaluating sine, cosine, or tangent of an angle. Now let's proceed. If it's in the second quadrant, we have this in the second quadrant. So we have angle 135 degrees, and we are asked to evaluate the related acute angle, x degrees. Now if we go back to our representation, in the second quadrant, the related acute angle is simply 180 minus theta, because the sum of angles on the straight line here is 0 degrees down to 180 degrees. So we are simply saying that x plus 135 degrees is equals to 180 degrees. So x is simply 180 degrees minus 135 degrees. 135 degrees is the theta, which still follows the formula of x is equals to 180 degrees minus theta. So this means that x is equals to 45 degrees. Let's proceed and take one last example. But then now we'll look at how to implement a negative angle. Let's take an example on the negative angle. Let's say we have minus 45 degrees. Now we have to draw a diagram. We understand that positive angle is clockwise, is anti-clockwise, and negative angles is clockwise. So in this vein now, we understand that our negative 45 degrees is here. So we have negative 45 degrees. Okay, we have direction already, so we have 45 degrees there. Now the relative acute angle in this case is what? Let's redraw now so that we understand. We have the Cartesian plane. We understand that the positive angle is anti-clockwise, the negative angle is clockwise. So we have negative 45 degrees, which is clockwise. So we are moving in the clockwise direction by 45 degrees. Now, if you recall back to the lesson we had on acute angle in the fourth axis, fourth quadrant, we understand that this will be our related acute angle for the fourth quadrant, so which is already represented here, 45 degrees. So therefore our acute angle in this case is 45 degrees. Let's take one last example, and still we'll be using negative angle. Let's take minus 135 degrees. Interesting. Minus 135 degrees. Remember that we had an example previously for 135 degrees. Now taking minus 135 degrees, positive angles, and we also have negative angles. Therefore minus 135 degrees, we start from the positive x-axis and move in the anti-clockwise direction. So 135 degrees in the clockwise direction will lead us here. So we have 135 degrees, and then we have this. So this angle is 135 degrees and it is in the third quadrant. The question now is, what is the related acute angle, which is x? Now we can just simply bring it out and say, oh, the sum of angles on a straight line is 0 down to 180 degrees. So we are simply saying that x plus 135 degrees is equals to 180 degrees. Okay, therefore my x, or our x, is equals to 180 degrees minus 135 degrees, which is 45 degrees. So the related acute angle in this case is 45 degrees, but this time it is in the third quadrant. Now notice this, minus 135 degrees is in the third quadrant, however 35 degrees is in the second quadrant. Minus 45 degrees minus 45 degrees is in the fourth quadrant, but then 45 degrees in itself, you can see it here, 45 degrees in itself is in the first quadrant. So this is very, very important. In the next lesson, we will take an exercise to ask us, we'll have a particular angle, we'll know we have to determine the quadrant and also have to determine the related acute angle. And afterwards, we'll move to trigonometric ratios of angles between 0 degrees down to 360 degrees.